welcome everybody. Take a seat. There's still lots of seats open here in the middle. I'm Lukas. I'm from Loft. We're the maintainers of vCluster and DevPod, and we're going to talk a little bit about developer experience and dev velocity when building AI and ML applications on AWS. So as I mentioned, vCluster is the open source project that got us started in 2021. We launched that project on GitHub, and it's essentially a tool to create virtual Kubernetes clusters. So that's really what most people know us for. vCluster has about like 6,000 GitHub stores at this point. There's about 3,500 folks in our Slack community. Fortune 500 companies have adopted vCluster. There's about 40 million image pulls when you're looking at Docker Hub, GitHub registry, et cetera. And here are some of the companies that we're working with currently. You can see some of the biggest companies, unfortunately, don't want us to put their logos there, right? So you can see chip manufacturer, Big Four, global accounting firm, electronics giant, right? You can probably think of who these companies might be. We recently raised a Series A round by Khosla Ventures earlier this year. It's a $24 million round, and are building the company from here. What we're doing with vCluster is essentially, looking at what enterprises do with Kubernetes. When you're running EKS, so, it's pretty straightforward. You can, a couple clicks, spin up a Kubernetes cluster. That was a lot harder when I got started with Kubernetes back in the day. But right now, it's pretty straightforward. So companies create a lot of Kubernetes clusters, right? They create one per team, per customer, sometimes per environment, dev, staging, prod, QA, right? And then what you end up with is hundreds or even thousands of Kubernetes clusters. And that's very, very expensive, right? Because you're running all of this tooling in each cluster. You're obviously paying for the cluster fee in EKS, right? The cost adds up really, really quickly. So what we invented is a technology to run things in the same Kubernetes cluster, but still give developers the autonomy to feel like they have a completely separate Kubernetes cluster, right? We call that virtual Kubernetes cluster. That means essentially in a Kubernetes namespace, you spin up a container that has an entire Kubernetes cluster inside, and now you can hand that Kubernetes cluster out to an engineer. The big benefit of that is, when you have completely separate clusters, everything is separate, right? That means everything needs to be duplicated, right? Networking, monitoring, security, all of these tools, the VMs, the underlying, EC2 nodes, right? Everything is completely separate. So you have a lot of idle time. You have a lot of duplicated resources, a lot of wastage across the board. With vCluster, it becomes a little easier, right? You can essentially have a central cluster. And in that central cluster, or like if you're a really big company, you're probably not just going to have one cluster, but instead of 100 or 1,000, you're going to maybe have 5, right? And then in these 5 clusters, you run your standard tooling, you create namespaces, you create these virtual clusters, you hand them out to engineers, and they feel like they got a full-blown EKS cluster, but in reality, they don't, right? And the really cool thing about this is as well, you can turn on and off these virtual clusters, right? That means, it's just a container, right? So it's pretty straightforward to get rid of it, fire it up again, have the state persisted in a persistent volume, pretty straightforward. Ultimately, you're going to have fewer clusters. You have that lightweight layer of virtualization, and then you have that shared platform stack, right? And that really drives down cost for a lot of the enterprises that we work with. But why are we ending up in the first place here? And that's what I want to talk about today. And that's the second open source project we recently launched. And the majority, of this talk is about, essentially, why do people spin up these clusters in the first place? Why do we spin up so much infrastructure and hand it out to folks? Well, it's because, we heard it earlier, we live in this new world, right? We have a lot of data-intense applications is how we typically refer to them. AI applications, ML applications, you need access to training data, right? Very high resource consumption for running some of these applications. You need potentially special hardware that you just don't have laying around in your home lab, right? So you need to run on a remote environment, right? And obviously, Kubernetes is a great API to hand out to folks to launch workloads, right? That's why, when you read like OpenAI's, blog posts and stuff like that, you see a lot of mentions of Kubernetes, right? And that makes a lot of sense because Kubernetes is a large-scale distributed system, lets you scale up pretty, infinitely in terms of the workloads you're deploying, right? It's really great to launch these workloads. And obviously, it's a standard abstraction layer, independent of where you're running, right? So there's all these new, like, GPU cloud providers coming up, obviously AWS, Google Cloud, et cetera, right? There's a lot of new hardware coming in these cloud platforms, but we don't need to necessarily know the intricacies of everything. We can just have a standardized, compute layer that we're talking to, and Kubernetes, is a great way to abstract things. Access to large data sets, right? So let's say you have S3 buckets, right, with a lot of data in there, right, or RDS, right, or whatever it may be, right, where your data is located. It's much easier if you're running applications when they consume a lot of data directly at the source of that data, right? So if you're already in your corporate, VPC in AWS, and accessing the data there, much lower latency, right? Especially if you need to, access large quantities of data. Do you really want to have that like egress traffic, right, to some other location, right? Do you want to pull that data down to your local machine, right? You can't pull the whole thing, right? There's all these kinds of problems. So just operating closer to the source of that data makes things a lot easier. And then you have usage spikes, as I mentioned before, right? And that's what the cloud is really great at, right? Like if we think back of like the AWS kind of origin story, right? Like AWS Amazon creating all of these resources internally, for like Black Friday and like all of these like special events, and then saying like, hey, the rest of the year, I don't know, right? And that's ultimately how EC2, got started. So the cloud is really great for these kind of scenarios, right? But we got to think about developer experience and like how to hand out these environments, right? Because it doesn't really stop with handing out Kubernetes, right? With vCluster, you can obviously minimize the cost of handing out Kubernetes drastically. Would you give every engineer in a 10,000 engineering strong organization their own EKS cluster? Probably not, right? With vCluster, you can actually give everybody their own cluster. You can give everybody 5 clusters if you need to, because maybe 4 of them are, put to sleep and when they're running idle, and only the one that they're actually working on is starting. But that's what we solve with vCluster, but it doesn't stop there. When you hand out a Kubernetes cluster, the question is, okay, how do I interact with that API now, right? I'm an ML researcher, I'm a data scientist, right? I'm somebody, training LLMs, right? Do I really want to deal with like how things work in Kubernetes? No, I just want to launch my applications. I want to consume that infrastructure without necessarily being on the layer below. And that really matters a lot. So why we care about developer experience and velocity is we want to reduce time to value, right? We want to actually build applications that ultimately are used by a lot of folks. So we want to reduce the time until we can produce that value for the end user. We want to enable team growth, right? When you're thinking about, companies hiring, all of these new, right, folks coming in, building these data-intense applications, you obviously want to get them up to speed as quickly as possible, right? So you think about how can we standardize things across the board, right? How can we reduce friction during onboarding, right? Everybody's probably familiar with this. You join a large organization. It's really, painful sometimes to get started, right? It may take a week till you write the first line of code and are actually able to execute something, right? And then switching projects becomes a lot faster as well when you're potentially moving things away from your local machine, right? Because you can just pick things up directly. That will be fantastic, right? So how do we get there, right? What options do we have, right? Obviously, we can build internal tooling, right? That's always an option. That is a lot of effort, though. It's really hard to get right. And it's even harder to maintain over time, right? Sometimes we see companies building that, and there may be 1 or 2 people really passionate about developer experience, right? They're building internal tooling. And then what happens if that person leaves, right? Becomes a really big burden for the organization. And even some of the biggest organizations, it's only a handful of people who are truly involved with these initiatives. So that's option number 1. You have cloud-only IDEs. I think AWS recently deprecated Cloud 9, actually, which was one of the first generation cloud IDEs, right? Browser-based experiences. And browser-based experiences, were hot around like 2015, 16, when I think, Cloud 9 and CodeEnvy, and I think coding was another one, right, came up. And I think Cloud 9 is probably the one that survived the longest until now, right? But that's really the first wave of these experiences of like, how can we get people up to speed? How can we equip them with, cloud native resources directly from the start? Well, we'll just pop up the browser, have them work there, right? So your AWS console just opens a new tab, right? And you start coding there. That is a shift though from your local environment, right? So you may be restricted in certain ways, right? You may not have, the customization capabilities that you have on your local environment, and we all know this, right? Telling 1,000 engineers everybody's going to use the same IDE, probably not going to go super well, right? As engineers, we are pretty opinionated about the tool stack that we're using and how we're working, right? That's why we got like, I don't know, 80 million programming languages and databases, right? There's variety for everything, and there's a place for a lot of different sets of tool stacks, right? In our company, there's lots of folks, using different kinds of IDEs, right? And we don't really care. It's like whatever you're most productive with, right? So that is a little bit of the problem of this first wave of cloud IDEs. The newer cloud IDEs in the past couple of years, right, Coda, Gitpod, DevFile, right, are trying to establish standards, and for the majority of this, they have some kind of an open core model, right? So there's a part component open source, and then on top of that, they're essentially introducing a certain file. I think like Gitpod, for example, has this Gitpod YAML file, right? Where they're essentially saying this is the way to encode the dev environment. And then we spin up the IDE on top of that. And the IDE can run locally, it can be VS Code, or it can run the browser, right? And then you have GitHub Codespaces, which I think is the last step in that evolution of like trying to get to a consistent experience, spinning up environments quickly, and attaching the hardware from the cloud really, really quickly to that environment, right? The reason why Codespaces is great is because it's GitHub, right? And they put this button, I think, like pretty much everywhere on GitHub now to, GitHub Codespace is based on this dev container JSON file. And that's the only thing you really need in your Git repo in order to define, what a dev environment looks like and, how that connects to the underlying infrastructure. And I think Codespaces is great because it's directly integrated in GitHub. And obviously, a lot of us work on open source technologies or, at least interact a lot with open source technologies, right? So obviously, very great that that's directly integrated there. But the issue with Codespaces is, unlike the Coda, Gitpod, DevFile, and even some of the cloud-only IDEs, Codespaces is a service, right? It's a SaaS. And obviously, with AWS Community Days, so what if I want AWS hardware instead of, I guess Azure is running under the hood is what I would assume if it's GitHub, Microsoft, right? What if I want this in my own VPC in my AWS account, right? Well, that doesn't work with Codespaces today. What if I'm using GitLab or Bitbucket or a different code repository? That doesn't work either, right? Obviously, it's great if you're exactly in that stack and that's fine with you. But if you're going outside of that stack, right, it's a little problematic. So we looked at this last year, and as I mentioned earlier, we work with a lot of people that create a lot of Kubernetes clusters, right? So obviously, the intention to create dev environments on top of Kubernetes is a dominant use case among our user and customer base. So we asked them about this, and they were like, yeah, it would actually be great if we had something that was similar to Codespaces, but would work in my AWS and my VPC on EKS, right? And that's essentially why we started DevPod. So DevPod is a way, and we kind of put it very provocatively, A, on the slide, but B, also on Hacker News, and said like, it's Codespaces, but open source, right? And that project blew up pretty quickly on Hacker News and has about like 8,000 GitHub stars or so within about a year or so. It's a pretty new open source project. And it has 3 design principles. The first one is, as I mentioned, open source. That's a really key one, right? I think we have a Mozilla license for DevPod, so it's completely open source. And the second one is client only. And that's really interesting because we looked at what some of the most successful projects out there are that let you consume and spin up infrastructure. And one of the key projects out there is Terraform. And Terraform is really great because I can just download a CLI essentially and then spin up resources as long as I have AWS credentials, right? And then the second thing that's really great is that they have this provider concept, right? And that's our third principle here. We want to be relatively unopinionated of where do you run things, right? So similar to Terraform CLI, it's client only. And similar to Terraform, we have a provider concept. That means in the provider concept, you encapsulate all the logic that communicates with AWS or with Google Cloud or with your own custom provider that talks to something in your private cloud, right? You can just write that provider yourself, just like you can for Terraform. That's what we mean with unopinionated, right? What we also mean with unopinionated is solving a problem that I was referring to earlier. It should not depend on a specific IDE and a specific stack, right? It should work with pretty much any language. It should work with pretty much any IDE, right? Because we know there's so many different use cases out there, there are different teams, right? There are different preferences within the same team, right? That's what we really mean with unopinionated. DevPod ships as a desktop application, which was actually new for us because we're deep in the Kubernetes world, so everything is like API, infra layer, right? YAML, right? But when we were thinking about a developer experience tool, and we did build CLIs before, but the developer experience is so much easier if you just have a desktop application. So you download the desktop application, run it locally, connect it to your infrastructure, and then you can spin up consistent dev environments. And the main concept in DevPod that you can see is a workspace. Workspace essentially defines, there's my code in there. It runs on a specific piece of infrastructure, and I'm connecting it to the IDE of choice. The IDE is the one that you can really easily change, right? Obviously, the infrastructure and the code is a little bit more tricky to change once you have that workspace set up. The dev environment always runs as a container ultimately, right? That is the most top layer, which makes it very flexible, similar to what the dev container JSON ultimately provides. And it has a start-stop functionality, and that's really important in the enterprise context, and especially for these ML AI workloads, right? Because if you provision a lot of infrastructure, that's very expensive to run, right? So you don't want to keep that running forever. You want to have the ability to stop it, right? And DevPod comes built in with a start-stop and actually an automatic stop functionality, right? So we actually detect when the work environment, the workspace is idle, and then it self-shuts down. Even when you take your laptop, you throw it out the window, right? There's this lightweight agent in the workspace itself that self-shuts down when it sees no incoming connections, right? That's how it works under the hood. And then obviously spinning it up, the desktop client just connects to the environment again, right? Fires it up. The other important thing is DevPod in its core is built on the dev container JSON. Because as we said earlier, when you look at the evolution of some of these tools, right, all the way from like, Cloud9 back in the day to today with code spaces, it's pretty clear that, this open source standard, dev container JSON as a standard is actually open source, while GitHub Codespaces is a SaaS offering and not open source. It was pretty clear to us that with the backing of like GitHub, Microsoft, right, and then building tooling around it in GitHub and also in VS Code, that the dev container JSON would evolve to be a winning standard, right? So we wanted to make sure it's 100% compatible. So we built DevPod on top of the dev container JSON standard. That means we actually don't try to compete with Codespaces. We're trying to complement it, right? Because when you're working on GitHub and you're fine with having your code in, that SaaS layer and not have it in your own infrastructure, there's no reason why you would want to use DevPod, right? But if you fall outside of these parameters, you're saying, I'm on GitLab, right? I want this in my AWS VPC, right? Like I have certain things in my private cloud, right? All of these scenarios, DevPod is a really great complement. And you can switch back and forth, right? Because it's 100% compatible. It's exactly the same definition. And then, as I said, there's the connection to the underlying infra layer, and that's what we call providers. And you see a couple of logos up there. Obviously, we support, Docker on your local machine, even to spin up a dev environment, because as I said, it's just a container-based definition. You can run dev environments in Kubernetes. You can just give us SSH credentials, right, and hook into an existing, machine in your home lab. But you can obviously also connect via AWS, Google Cloud, et cetera, to spin up environments over there. Typically, how it works from a provisioning standpoint is first the provider gets initialized. What we mean by that is we validate, do you have credentials for AWS or whatever is needed to spin up that environment. Then number two is we're creating a machine. That is optional in case you have something that can launch containers straight away. So obviously in Docker, there's no machine to be created. We just talk to the Docker daemon, launch a container there, right? Kubernetes, same way. We just fire up a pod, right? We don't necessarily need to create a VM and attach a node or whatever, right? But if your provider is EC2 based, right, and you're saying, hey, I want an EC2 instance as my underlying infrastructure, then what we do is we create a EC2 instance. And then number three, we launch the dev container, which is the actual workspace, right? We inject the code, we get your Git repository in there, we potentially mount other pieces of infrastructure as you defined it, right? Think of like S3 buckets, et cetera. There's a lot of things you can define in the dev container JSON. And then we launch and connect your IDE so that you can start coding within that container. And this is how it looks when this is actually fired up. So we use the remote extension in most of the IDEs where that's available. And as you saw earlier on the screenshot here, we support a lot of IDEs already. I think that list is actually 3 rows long, and it didn't fit in here at this point. But even like Jupyter Notebooks, for example, right? And what we do is we typically have a SSH connection to the remote environment. So in that container, there's a lightweight SSH server, and that is also the one that detects, hey, do I have connections? If not, I'm shutting myself down, right? And then, what we do additionally is through the port forwarding, you'll be able to have access to anything you want to test, in the browser, or you have like, run a curl command or something like that outside. I guess you could run that in the remote terminal as well. And typically in your IDE in VS Code, for example, you have that indicated at the bottom left, right, that you're currently not working on your local file system, you're working on the remote file system, right? So when I make changes to a file, nothing on my machine changes. I'm actually changing files directly in the remote system. It's via SSH. When I'm typing a command in this terminal here, right, it actually happens entirely remotely. Nothing gets executed on my local machine if I'm in that environment. But I feel like I'm working on my local machine, right? My experience doesn't change. I don't become less productive. I'm not limited, right? It's my VS Code on my local machine, but it proxies everything, right? Like the file system, the terminal, right? And that's a really great experience because we don't need to retrain people, have them work in the browser, right? Like that, you can still have your extensions in VS Code, et cetera, right? The workflow stays exactly the same. And then underlying, as I mentioned earlier, the providers, they're based on the provider concept. The provider concept is defined as YAML. We're Kubernetes people after all, right? So although dev container JSON, right, for providers, we're using YAML. So provider you see here is a couple lines of code. It's the Kubernetes provider, or it's like the very, very first version of the Kubernetes provider, actually, when I took that screenshot. And within a couple of lines of code, I can just teach it how to talk to Kubernetes. So I can also teach it how to talk to my specific cloud provider in Europe, because I want this to be GDPR compliant or something like that, right? Or to talk to my home labs, you know, server or my Raspberry Pi or wherever you want your work environments ultimately to run. And yeah, I wanna demo this real quick actually. And bear with me, live demos are always dangerous at a conference with, especially when you have a remote environment, so internet connection is required for this. So let's see how this goes. All right, so this is DevPod as a desktop application. Let me minimize this here. I hope the fonts are all right in terms of size. We see here when we go to providers, we have a couple providers connected. For example, we have local Docker connected. That means you know, I can just spin up things with my local Docker daemon. We also have AWS connected, obviously, right? Because this is an AWS-focused event, right? You could, however, also, you know, add the competition here, I guess. And then we also see DevPod Pro. That's a little bit of a server-side component that we introduced that allows you to share credentials, right? And that's how you kind of understand like what the business model behind it is, right? If you don't want to hand AWS credentials directly out to everybody and want to have like a sharing mechanism, key rotation, those kinds of things, that's what we layer in on top. When we look at these providers, pretty straightforward. We can click, you know, add provider, add a new one over here, right? Click custom provider and just essentially provide the Git repository or load it from a folder, right? If I locally create that provider YAML file to develop a new one. So that's a requirement that you at least have one provider set up. And you know, the AWS provider in this case is just using local AWS CLI, right? So pretty straightforward. I'm authenticated already on my local machine with AWS, did the SSO, etc. Hopefully these credentials are still valid when I typed them in last night. And then you can see here for spinning up a dev environment, I have a couple options. I can load it from a local folder if I already have it, you know, checked out on my local machine, which we typically encourage people to do anyway, because let's say, you know, let's say you're building a data-intense application, probably, you know, we heard earlier, like 1 hour a day is actual coding time. Now think about like how much of that time do you actually need in a week in a remote environment, you know, potentially not the entire 40-hour work week, right? But maybe for 3 hours, right? The remainder of the time, I can run things locally, right? And that may be sufficient. I'm just running unit tests, right? But then when I really want to train on my full data set, then I'm going to use my AWS-based workspace, right? And then in this case, I'll just go with Git repository. We have a couple of samples here, quick starts. We'll just go with Python because, you know, obviously Python is pretty data intense. Typically, lots of libraries for there. We can hover over the provider here. We see this is hosted in California, US West 1. So hopefully the latency shouldn't be too bad despite the conference internet connection. So I'll choose AWS here as a provider. I can pick my IDE. That should pop up by default. I'm just going to go with VS Code. That's my go-to. And hit Create Workspace here. And hopefully the demo gods are with me. Looks good. So what happens is the provider gets initialized. So we're checking, do you have the credentials to fire up things in EC2 in this case. It's configured to use EC2 under the hood. We can actually go into the AWS console here and check it out. Let me refresh this. There's our new instance. You can see this instance was created, yeah, 1 minute ago or like a couple seconds ago. So this is firing up, using extra large because we're feeling generous today. And then in a couple of minutes, this instance should be completely up and running. The next step that happens is, you know, Docker gets injected on that EC2 instance, so it's fully automated. The only thing I clicked was AWS and, you know, create workspace. So the experience for me as a user is really simple, but there's a lot of things that happen under the hood, right? Now this dev environment gets spun up as a container within that Docker daemon on the EC2 instance. And if we're switching back to the console, you get a trace of everything that happens here, right? So we're pretty verbose. There's also a debug mode you can enable, which is even more verbose and really going under the hood of what happens here. And we're seeing now, you know, Docker is firing up, and then ultimately that container gets launched. I think I think the Docker install process is still running. So the first time I'm spinning up this dev environment, it takes a little bit longer because that VM needs to be equipped with the right kind of things, right? There's also a way to say, hey, I'm using specifically pre-equipped like VM images, et cetera, right? Then obviously that process can be accelerated. Now we're seeing Docker is ready to go, and we're pulling the image, right? You've probably seen this kind of screen before on your local machine when you work with Docker. So we're pulling the image, pull complete, a couple more layers to pull. And then once that is ready, that SSH connection gets established, right? That agent gets injected, and the local environment is going to be connected to that remote container. And we'll see that in a second. There we go. So this is our VS Code now popping up locally. And we're seeing on the left bottom corner here, opening remote. And now we're ready to go. On the left-hand side, we're seeing this project now. We can switch over to terminal here. And you can already see that we're in this workspace context, right? I don't have a folder workspaces on my machine. But on this remote container, I have that, right? We can take a look in here. There's all of our files. We're seeing our files over here. And we can check out potentially the README here. And see, this is a simple, we're actually using the dev container, the GitHub code spaces dev container JSON getting started project to really show them, like, we don't have a separate getting started project for Python. You just use whatever, GitHub code space lets you do, because we're 100% compatible, right? And thankfully, they prepared a great demo here. So what we can do now is we can just, this is a Flask application. I can just copy the command out here, run that down there, open the app in the browser, right? Because we have the port forwarding going, right? Pretty straightforward. I'm up and running as an engineer. There's nothing I needed to install locally. I mean, I had VS Code, right? But I never had to install Python. I never had to install Docker, none of that, right? The only thing I needed is the AWS CLI and authenticate with it, right? Hopefully my admin overlords gave me access to spin up an EC2 instance or reuse an existing EC2 instance. That's also an option. And I'm ready to code now, right? And what I can do now is I can change, anything in here. There's no file synchronization, et cetera. It happens immediately in that running container, and I should, be able to see that change right away. It feels completely local. Even the address up here is local because of the port forwarding, right? But if I wanted to, collaborate with somebody on this and hand it out to somebody else, this runs in EC2. It's really easy, right, to give somebody else access to that same work environment. And it's also very easy for somebody else to get exactly the same experience, but potentially with a different IDE or potentially in a different piece of infrastructure, right? And that's really the beauty of this. It really allows you to mix and match between certain things. And last but not least, what I'm going to do is I'm going to close the IDE over here. And unfortunately, I set my timer to 5 minutes to automatically stop this environment. And the talk's over in 5 minutes. So it may not be enough time to see how this environment gets wiped out of EC2 again. Well, it doesn't get wiped. It gets, the EC2 instance gets, stopped. And then if I hit here the 3 dots and I click delete, then the EC2 instance also gets cleaned up and everything that got set up, right? Pretty straightforward. One of the recommended setups we tell people to follow is to also have a local environment set up. So you use a dev container JSON with a local provider, like Docker, for example, right? Or just directly on your local machine, right? And we use the remote environment, and then you can switch back and forth between the two, right? That's a pretty neat experience as well for folks. Yeah, it seems like the demo worked. Yay. Thanks so much for attending this talk. I know we have 3 minutes left for questions. Happy to answer any questions.
Yeah, how if you're used to working in iTerm, for example, how easy would it be to just SSH to the instance? Like, how visible is that name, the host name?
So Oh, I think the screen's gone, but oh, there we go. So the SSH provider is pretty straightforward. We can actually do it here. Just click SSH, right? And then I'm not sure if do I have a HSS? It's a long time since I SSH'd into a machine. I don't think I have anything local, but if you can run locally, right, you have your credentials in your local folder, right, in your user folder, right? You just provide the host here. There's a couple options. Obviously, you can specify, but by default, right, you just say, hey, SSH, and then host, and my credentials, my key, right, is in my home directory. It's just going to reuse that credential, right? And it would inject Docker directly. Obviously, it needs to be a machine that lets you install Docker, right? That is a little bit of a requirement. Yeah, you'd see it like any other workspace up here, right? Oh, that's another good point. So by default, most of our providers, I'm not sure if it's actually in the options for this one. Yeah, let me go to AWS. I'm a little bit more familiar with AWS provider. Configuring a second one here. There's this toggle here, reuse machine. And that actually means I can spin up multiple environments, right? Multiple dev containers on the same EC2 instance, right? Because I said earlier, it takes a little bit of time to obviously install Docker. You saw it earlier, it takes like 3 minutes or so, right, to get that EC2 instance ready in order to deploy workspaces. So you may want to have multiple workspaces. And the really cool thing is the workspaces turn off, right? So the container shuts itself down, right? And when all the containers are down, then the VM goes down. I had that in a diagram earlier, and I didn't go really into the details, but the agent, we're injecting it in the container as well as on the machine, right? So the agent on the machine watches, do I have any dev containers running? And the containers themselves watch, is anyone connected to me, right? So if you have 5 dev environments running, typically just one is active, right? And you free up resources for your work in another environment. So that's really handy if you work on 3 different Git projects and you switch back and forth, right? But you're using the same EC2 instance or machine in your home lab, for example. Yeah, there's a question over here.
Hey, so how do you, we were talking about data-intensive apps, right? Creates an EKS cluster or GCP, Kubernetes cluster, whatever. How do you go ahead and how complex is it to say, like, that cluster can connect to my database or my data lake or my S3 buckets? Obviously, there's Amazon stuff or Azure stuff that happens, but kind of we glossed over that in this presentation. What DevPod specific configurations are needed there?
Yeah, so DevPod doesn't help you with connecting to AWS services directly. And I think obviously a big benefit of running a container directly in EKS, for example, is that you can set up workload identity in AWS, right? And pod identity, I think is how it's called now, right? So essentially, your pod gets a binding to a certain IAM role and has permissions to do things in AWS, right? And that makes it really easy to say, hey, you can create S3 buckets, or you can, launch things, right? And that's typically how it would work, or access an RDS, right, for example. But DevPod doesn't necessarily help you with any of that. DevPod just helps you get into that container that runs in EKS, right? But then from there on, you still gotta, connect whatever sources you need to connect to that container.
All right. And with that, we are at time for this talk. Please thank our speaker for the excellent talk today.
Thank you.
And if you have any more questions for him, you can find him outside. And we'll get started on our next speaker in just a couple of minutes. Thank you.